Bismillahirrahmanirrahim. My name is Zubair Ahmad. Today we start the concept of limit and some related problems of the limits. Now, yesterday we discussed about the concept of limit, left hand limit and right hand limit. If limit of the function exists, it means finite. It means left hand limit exists equal to right hand limit exists. Now look at first problem. You limit x tends to 2, x minus 2 over radical 2 plus x. Now apply limit x tends to 2 in this function. What we get in place of 2, 2 minus 2 over radical 2 plus 2. 2 minus 2 means 0. 0 upon radical 4 and 0 upon any number equal to 0, and you know that 0 is any finite number, and it means limit of the function x minus 2 over radical 2 plus x when x tends to 2 is exists and equal to 0. Now second problem, limit x tends to 1, x cube minus 1 over x minus 1. Now in first step, if we apply limit here, x tends to 1, then what we get in place of 1, 1 cube means 1 minus 1 over 1 minus 1 means 0 upon 0, and you know that 0 upon 0 is meaningless or indeterminate expression. Whenever we get this type of expression or indeterminate form, we need to try further work out on this problem. Now, what further work out? It means you take factors of x cube minus 1. Now, what is factor of x cube minus 1? X minus 1 and x squared plus x plus 1 divided by x minus 1 same. This is same factors like x cube minus a cube minus b cube. Here what is a is x, what is b? B is 1. Now x minus 1 and x minus 1 cancel. We have x square plus x plus 1. Now apply limit on x square plus x plus 1. Now what we get? 1 plus 1 and 1, we get 3, and 3 is finite number. It means limit x tends to 1 on this function is exist and equal to 3. Okay, again another example, another problem. Limit x tends to limit x tends to 1, 1 upon 1 minus x minus 3 upon 1 minus x, 1 minus x cube. What we get? Now in first step, always we apply limit directly. What is limit? X tends to 1. Apply here. What we get? 1 upon 1 minus 1. 1 upon 1 minus 1 means 1 upon 0. You know that 1 upon 0 is infinity. Minus 3 upon 1 minus 1, again infinity. Infinity minus infinity is indeterminate expression. It means we need to further work out in this problem. Now again here 1 minus x is only linear equation, no need to further work out. Here is 1 minus x cube. Try to find factors of 1 minus x cube. Here 1 upon 1 minus x minus 3 same factors are 1 minus x cube, 1 minus x and 1 plus x square. Okay, now take LCM. What is LCM of these factors? 1 minus x and 1 plus x square. Take LCM and 1 minus x cancel, we get 1, and here 1 plus x square minus 3. Okay, here 1 and minus 3, we get minus 2, and x square plus x upon this. Again x square plus x minus 2. What is factor of x square plus x minus 2? You apply quadratic equation or by factorization. factors are x square plus 2 and x minus 2. If you want to check these factors are correct or not, again multiply x plus 2 with x minus 1, you'll get same result. And upon 1 here, this is 1 minus x. If you multiply minus 1, then this will be x minus 1 and 1 plus x square. Now these are the common cancel. What we get, x square, x plus 2 upon 1 plus x square. Now you can easily apply limit. Limit is 1, so here is a 1 plus 2, 1 plus 2. Here apply limit 1 plus 1 minus 1 plus 1 plus 1. What we get, 3 upon minus 3, 3 cancel, we get minus 1. Again limit x tends to 1 on this function is exist and equal to minus 1. Now in fourth problem, limit x tends to 0, cosec x minus cot x upon x. If we apply direct limit x tends to 0, again we get 0 upon 0. So this problem equal to limit x tends to 0, cosec equal to 1 upon sine x minus cot x equal to cos x upon sine x, and this x is 1 upon xn. Okay, again you take LCM. What is LCM? LCM is sine x. Again sine x, again 1 minus cos x over sine x into 1 upon x is same. Again if you apply limit, then what we get, cos 0 0. Cos 0 is 1, 1 minus 0, 1 minus 1, 0, sine 0 is 0. Cos 0 is 1, sine 0 is 0. Then again we get 0 upon 0. It means we need to further simplify it. It means rationalize, multiply and divide by 1 plus cos x upon 1 plus cos x, because here is 1 minus cos x, then we multiply 1 plus cos x. If here 1 plus cos x, then we multiply 1 minus cos x. This is called rationalization. Now multiply numerators and denominators. What we get, if you multiply numerators, here a minus b and a plus b, you get a square minus b square, and here is sine x 1 plus cos x, okay, into 1 upon x is same. Here is also 1 upon x, okay. Now 1 minus cos square means equal to sine x, sine square x, and in denominator sine x 1 plus cos x into 1 upon xm. One sine cancel from here, then what we get, this from one sine is remaining sine x, and this x here, this is sine x upon x into limit x tends to 0. Here is 1 upon 1 plus cos x. We have two terms. Okay, now apply limit sine x upon x into 1 upon 1 plus cos x. Then sine x upon x, what is sine x upon x? Sine x upon x, limit x tends to 0, this equal to 1. This is useful limit we did last time. And apply limit here, cos 0 equal to 1, 1 plus 1 is 2, and here is 1, and here is 1 sine x upon x, limit x tends to 0 is 1, and 1 plus cos 0 is 1, 1 plus 1 is 2, result is 1 upon 2. Again limit x tends to 0, okay, it means again limit is exists and equal to 1 upon 2. Now move another problem, limit x tends to 0, sine ax upon bx. Okay, sin ax upon bx. In first step, you apply direct limit. What is direct limit? Sin x tends to 0. Then what we get? Sin 0 upon sin 0. Sin 0 is 0 and sin 0, 0 upon 0. Okay, 0 upon 0 means meaningless or indeterminate form. It means you need to simplify further. Now, in last problem, you know that sin x tends to 0, sin x upon x equal to 1. See here, limit x tends to 0, sin x upon x equal to 1. It means if sin has angle x, then same angle in the denominator, result will be 1. Now same thing is here, sin ax, if ax divided by sin ax, and here's a sin bx, and sin bx also divided by bx, then will be equal to 1. Now same thing, here you apply sin ax divided by ax into ax upon bx into bx upon sin x. See here, bx and bx cancel, ax and ax cancel, then we get same this sin ax upon bx. Okay, we can easily check, multiply and divide by ax and bx. Now sin ax upon x here, and this ax upon bx, xx cancel, and because this is a multiplication rule of the limit, if we have n function in multiplication, then limit will apply on each term, each n term, first term into second term into third term into n term. That's why here is 1 2 3, limit apply on this function and this function. X cancel. Now what is limit of sin ax upon x equal to 1? This is useful limit. And a upon b constant, the same ab. And apply limit here. Sin x tends to 0, we get a get 1. Then this equal to a upon b. It means limit x tends to 0, sin ax upon sin bx equal to ab. Ab is finite number, so limit is exist. Again, another problem, limit x tends to 0, 1 minus cos x upon x squared. Now 1 minus x is 1 minus x squared. In first step, apply direct limit. What is cos 0? Cos 0 is 0, you already know. And 1 minus cos 0 means 1 minus 1. X0 means 0 upon 0. This is again undefined. So it means now you and multiply and divide by 1 plus cos x. Then what we get if you multiply and divide? Here is 1 minus cos square x, and here is x square, and 1 plus cos x. 1 minus cos square means sine square. Sine square upon x square, and you simply write sine x over x whole square into 1 upon 1 plus cos x. Now here sine x upon x, limit x tends to 0, then this is again useful limit. Sine x upon x when x tends to 0 is 1, and there the square 1 square, and apply limit here 1 upon 1 plus cos 0, cos 0 equal to 1, 1 plus 1 equal to 1 upon 2. it means 1 upon 2, again finite number, and 1 upon 2 is finite number. It means again limit is exists, and equal to 1 upon 2. Again another problem here, 7, limit x tends to pi, 10 sin x over sin x. Now 10x tends to pi, 10x, 10 sin x over sin x. If you apply direct limit here, 10 sin pi over sin pi, this is again 0 upon 0 form. That's why here we replace this angle sin x by z. Then z equal to sin x, and over limit is x tends to pi. If you pi put here, then z tends to, here z tends to 0 because sin pi equal to 0. Now this problem, limit x tends to pi, 10 sin x over x equal to limit z tends to 0 because new limit is 0, and here is a 10 in place of sin x, z over z. Again limit z tends to 0, sin z over, because 10z equal to sin z over cos z. This you already know that what is tan, what is cot, what is cosecant, what is secant. In place of tan z, you can easily write sin z over cos z into z sem. Okay, now the sin z upon z into this 1 upon cos z. Now when you apply limit z tends to 0 on sin z over z, this is again used to limit equal to 1. And here apply limit z tends to 0, 1 upon cos 0, 1 upon cos 0 equal to 1. 1 into 1, again limit is exist. Now the 8 number you can solve easily. This is the same type of the problem. Again you move on problem number 10. Now 9 also same. Now problem number 10, here 4x cube minus 2x square plus 1 over 3x cube minus 5. Here limit is x tends to infinity. Now in infinity problem, first of all we take common highest power of the x. Here what is the highest power of x cube? X cube take common. What we get? 4. 2 minus x plus 1 upon x cube, and from denominator also x cube common. Then what we get? 3 minus 5x upon cube. Here x cube cancel. Now apply limit x tends to infinity. Here's a constant term, 4 this will be same. Now apply limit here, 2 upon infinity. You know that any number divided by infinity equal to 0. Again 1 upon infinity, this is 0. 3 is a constant, same. 5 upon infinity, this is 0. 0 upon any number is 0. Any number divided by 0 is infinity, and any number divided by infinity is 0. Okay, now what we get is 4 upon 3. 4 upon 3 is finite number. It means limit of this function is exist. Again second limit, 11 number, x tends to infinity, 1 plus 2 upon x power x. Now limit x tends to infinity, 1 plus 2x. Again here if you multiply and divide by 2 here in the power form, then what we get? This is x upon 2 into 2. Again 2 will be cancelled. We can easily write this in this form. But when limit x tends to infinity, 1 plus 2 upon x, and power of this whole is reciprocal of this term. Here is 2 upon x, power is x upon 2, and this equal to e. Last time we proved this identity. limit x tends to infinity, 1 plus 1 upon x power x equal to e, but here is 2 upon x and power is x upon 2, and this whole term is equal to e, and square is same, this e square. Again, limit x tends to infinity, 1 minus 1 upon x power x, and this can be written in this form, x tends to infinity, 1 minus 1 upon x. Again, you multiply here power minus 1 here and here. If minus multiply here, again you get same result. Now here is 1 minus 1 upon x power, reciprocal of minus 1 upon x will be minus x. Again, this identity equal to e, and power minus 1 is same. Then e power minus 1 is e power minus 1. Okay, in 14 number, limit x tends to infinity, a power x minus 1 over x, where a is greater than 0. Now here in first step, if you apply direct limit a tends to infinity, you get again infinity upon infinity. This is indeterminate form. It means you need to further simplify this. Now suppose here a equal to 1 plus h. Okay, then limit x tends to infinity, a power x minus 1 over x equal to limit x tends to infinity, replace this a by 1 plus x, 1 plus h power x minus 1 upon x. Now here 1 plus h power x, apply binomial theorem. You remember binomial theorem, if a plus b power n equal to a power n plus n, a minus 1b upon 1 factorial, then 2 factorial, and so on. Now you apply limit x tends to infinity, 1 plus x h plus x minus 1 h square upon 2 up to so on, and this minus 1 is same upon x. Now it is 1 and minus 1 cancel, and you simplify this. Here's h plus x minus 1 h square upon 2 factorial up to so on, and this x and x also cancel because from here x is also common. Okay, then apply limit. When you apply limit x tends to infinity, h is same because h is constant, and here x minus 1 upon 2, this is infinity, is h square. It means this whole term is infinity plus infinity plus infinity plus infinity and so on. Then we get h plus infinity. Again, any term add in infinity, again result will be infinity. So limit of this function does not exist as x tends to infinity. Again, this is infinite x tends to infinity problem. The same, you apply directly apply limit, take highest power common and solve this. This is very easy. Again, in this problem, in 16, you take LCM and further solve. After solving, apply limits. If limit is finite, again limit is finite, it means this function, limit function is exists, otherwise it does not exist, but here is a finite. This is very easy. Again, limit x tends to infinity, x minus radical x square minus 1. Again, same, take rationalization. Okay, take rationalization and then solve this. Apply limit, result is 0. Again, is finite. Okay, this is also infinity problem. In 19, the same infinity, take x cube common from numerator, x power 4 from denominator, and then solve. Again here, now there are two ways to solve this problem. First, you take highest power common from numerator and denominator, then you solve. And second way, you suppose x equal to 1 upon y or y equal to 1 upon x, then substitute here values and solve. Result in both methods will be same. Again here, limit x tends to minus 1, x power 1 upon 3 plus 1 upon x plus 1. Now in this problem, you apply, suppose x equal to minus 1 plus h, then h equal to x plus 1. Limit is x tends to minus 1, then h tends to minus 1 plus 1, h tends to 0 from here. Now new limit is h tends to 0 and x replaced by -1 plus h. Okay, then apply here binomial theorem. Same binomial theorem, a plus b power n, and some term are cancelled. Finally, we get 1 upon 3. 1 upon 3 is finite. It means limit is exists. Now, see here, this problem of left hand and right hand limit. Here, limit x tends to 3 minus 0. It means limit, this is left hand limit. And problem is 1 upon x minus 3 minus 1 upon radical mod of x minus 3. Whenever left hand or right hand problem exists, then how to solve this problem? In first step, you replace x by limit. Given limit is 3, and if the left hand limit is a minus h. If plus 0 means right hand limit, then apply 3 plus h. Then what is h? H equal to 3 minus x. Now x equal to 3 minus h and h equal to minus 3. Then original limit is x tends to 3, then h tends to 0, because here you apply 3, 3 minus 3 is 0. Now this original problem, this equal to h tends to 0, in place of x put 3 minus h, again here 3 minus h, and solve this. We get minus 1 upon h minus 1 upon h. It means this minus 2 upon h. Apply limit x tends to 0. Minus 2 upon 0 is infinity. Minus infinity, it means limit does not exist. Okay, again this is left hand limit. Put x equal to 2 minus h, then h equal to 2 minus x. Original limit x tends to 2, then here put 2, h tends to 0. Now substitute here in place of x 2 minus h. Okay, here, and solve this. This is simple. We get finally 3 upon 2, and apply limit 3 upon 2 is 0, and 3 upon 2 is a finite number. Okay, and is the same type of problem, left hand limit. Now see here 25, right hand limit. Now in right hand limit, 1 plus 0 means right hand limit. Here we put x equal to limit plus h. Left hand limit minus h, here plus h, then h equal to x minus 1. Here x tends to 1, then h tends to 0. Now our new problem, this problem convert into h tends to 0, 1 plus h minus 1 upon this. Now to simplify this, finally we get h tends to 0, h upon radical h, radical 2 plus h, 1h cancel. What we get? Radical h upon radical 2 plus h, apply limit, we get 0. 0 is again finite number. This is left hand limit problem, same. This is limit problem. Again, see here, two-piece function. Here f of x equal to x square plus 3 when x is less than or equal to 1. Again, this f of x equal to x plus 1. This is the first piece when value of x less than or equal to 1. And f of x equal to x plus 1 when x is greater than 1. Whenever we get a two-piece function, then how we apply limit? Now then we will apply left as well as right hand limit. Here limit x tends to 1 from the left hand side and limit x tends to 1 from the right hand side. Where we apply left hand side? Where x is less than 1. This is left hand limit. And where x is greater than 1, we apply here right hand limit. Right hand limit f of x is this. Left hand limit f of x equal to this. Okay. Okay. Now solve this. Limit x tends to 0 means left hand limit. We get for left hand limit, we will get first piece x square plus 3. See here. Apply limit, we get 4. For right hand limit, we will take second piece because x is greater than 0. Now here we get 4 means left hand limit exists equal to 4 means left hand limit exists. Right hand limit exists equal to 4, but both are not equal. Limit is exists if and only if left hand limit exists equal to right hand limit exists. It means here both limits are not equal. It means our limit does not exist. Okay. Again, this is two piece of function. First piece is x square minus 1 when x is less than or equal to 2. Second piece f of x equal to x plus 7 radical when x greater than 1. Okay. For left hand limit, we will take this piece because x is less than or equal to 2. For right hand limit, we will take x is greater than 2 and then apply limit. See here. For left hand limit, x square minus 1, we will go 4 minus 1, 3. And for right hand limit, we get second piece, this piece. Right hand limit, we get 3. Left hand limit 3, right hand limit also 3. It means limit of the function exists. Again, f of x equal to x square when x is less than or equal to 1, first piece. Again, f of x equal to x cube when x is greater than 1. Actually, there is a typing mistake. This x cube must be here in this place, not this place. F of x equal to x square when x is less than or equal to 1. Second piece is x cube when x is greater than 1. For left hand limit, we will take x less than 1, this. For right hand limit, x is greater than 1. We apply limit. If both are equal, then limit of the function exists, otherwise not. Similarly, 31, f of x equal to cos x when x is less than 1. Again, f of x equal to 1 minus x when x is greater than 1. X cos x for left hand limit because less than 0. 1 minus x is greater than 0 for right hand limit. Okay, these are the limit problem. You try to practice. And if you have any question, you can ask me.